Hello, class. Today we're going to talk about section 2.1 and 2.2, which deal with frequency distributions and their graphs. Now, on your notes here, the first thing that you're going to fill in is the word frequency. Now, the important thing to remember about the word frequency is its counts. So you're going to be given a lot of data that you're going to count. And then what you're going to do is you're going to put it into a frequency distribution, which is going to be a table. So you're going to take this data and you're going to display it in a table. And you're going to count how many times each thing occurs, and that's your frequency. So if you notice, there's a bunch of different credit cards here listed. So what you're going to do is you're going to count the 4 different types of credit cards. The easiest thing to do is probably to highlight something a common color. So for example, as you're going through and counting Discover, then I'd count all the Discover, then I'd go through and count another one, possibly Visa, whatever you want to count next. Another card here is American Express. And then you have a Discover. I've got Visa, American Express, MasterCard. Okay. So what you need to do is you need to pause the video and you need to go through and you need to count this, because it's very important that you're getting practice. So if you notice, there's going to be a frequency distribution under this information, and you're going to record your counts. Now, when you get done with your counts, you need to make sure that it totals 50, because you can see this is done with 50 customers. They're accepting these 4 types of credit cards. So when you get done, total these and make sure that you have 50. Okay, go ahead and pause the video. Okay, so you should have gotten 11 MasterCard, 23 Visa, 9 American Express, and 7 Discover. And when you totaled, it should be 50. The total frequency should always equal the number of items in the data set. We started with 50 credit card transactions, so the frequency should sum to 50. And in statistics, you're going to see this right here, which stands for sum. So the sum, you'll see us use F for frequency. The sum of the frequencies should be 50. So now we're getting to a word called relative frequency. This word's very important because you're going to see that a lot as you do your work. And there is a formula that you will be using for that. So a frequency distribution is going to display how many observations are in each category. But sometimes we're interested in the proportion of observations in each category. The proportion of observations in a category is your relative frequency. Now, this is kind of like where you divide your part over your total. So you're going to take the frequency of each category and divide that by the total frequency. Okay, so we have it filled in with our cards, and it should total 50. The total is always going to be the denominator. So this is all going to be over 50. The part is going to be the frequency. So that's 11 out of 50. This one's 23 out of 50. 9 out of 50. And 7 out of 50. Now, what we're going to do is we're going to divide this to come up with a decimal. So we're going to take 11 and divide it by 50. That's going to be 0.22. Then we would do 23 divided by 50, 0.46. 9 divided by 50, 0.18. And 7 divided by 50, 0.14. So if you were to sum all of those right here, the sum 0.22, 0.46, 0.18, and 0.14 should total or be close to 1. So the sum of your relative frequency is equaling 1. So that's pretty much when you think about that as percentages, okay? Sometimes it'll get like 99.99 or something because you're having to round, but this is representing 22%. This is representing 46%, 18%, and 14%. So you can see right here, it's your data. Once you have that displayed, you can infer that most people are using a Visa with that information, okay? So again, what I was mentioning, that it may sum to like 1.01 or 0.99 because of some of the things that are being rounded, okay? So just know that you're going to be very close to 1. Objective 2 deals with the frequency distribution and constructing those. So to summarize quantitative data, which is data that we can actually do numbers with and it makes sense to do something with, we're going to use a frequency distribution, just like those for qualitative data. However, since these data have no natural categories, we're going to divide these into what's called classes. Now, classes are intervals of equal width that cover all values that you observe in the data set. Now, lower limits, this should make sense. It's going to be the lower part of the class. So that's going to be your lower class limits. They're going to be on the left. They're going to be the smallest part of your class. Then the upper limit, they're going to be the largest value. So those are going to be there on the right. That's going to be your upper limit. So notice this is going to be your classes, and you have your lower and your upper. So you'll see sometimes use lower class LC and upper class UC. And frequency is the number of times something occurred in that class. So between 0 and 4, it occurred twice. Now, please pay attention to the class width. Width is going to be going from top to bottom. So it's kind of like when you're thinking about, if you're doing the width of a rectangle, you are looking at this information right here for the width. So we are looking at the width on that portion right there. So the class width would be what is between 0 and 5. There is 5 units. So to get that, you can do 5 minus 0, or you can do what do I add to 0 to get 5. The class width should be the same between every class. So 0 plus 5 is 5, 5 plus 5 is 10, and 10 plus 5 is 15. So remember that you're going vertically because that's missed a lot. Okay, that's called your class width, and you'll see that sometimes abbreviated as CW. Okay, going to the next part. When you are looking at your class width, it is the difference between the consecutive class limits. So it's the difference between those limits. So you can take the difference from one lower limit to the next lower limit. So you can subtract, or you can ask yourself, what do you add to get to the next one? Okay. When we start constructing frequency distributions, you're going to see some different directions in ALEKS. Sometimes it's going to give you the class width, so you don't have to actually work and figure that out. And sometimes you're going to have to calculate the class width, okay? It just depends on the directions. If you get confused on a question, just screenshot it and email it to me, and I'll be glad to help you. So the directions here with another formula is to find the class width. You can take your largest data value, which is your maximum, and subtract your lowest, which is your minimum, and divide by how many classes it's asking you to make. And then you just start adding each of the class widths to the next one. Okay, so take a minute to kind of look over that, and then we'll start the example. Okay, so this is where you have to pay very close attention to the reading. So one thing it tells us is that there are going to be 65 vehicles. So when I do my counts, this does need to total 65. Another thing that it's telling me is we need to construct a frequency distribution. And it says start at 0 with a class width of 1. So what that means is we're going to have to start at 0, and then we're going to add vertically. Okay, so I'm going to put a 0 here, and then I'm going to add vertically. I'm going to go down, adding 1. Okay, now if you notice, this is 2 decimal places. So since we have 2 decimal places, we want to keep that in our data. So we don't want it to be 1. So we're going to say that possibly would go to 0.99. Now, once you've got that, you're just adding 1 straight down. Okay. Now, if you'll pause the video and get your counts, what numbers fall between 0 and 0.99? So this is where you have to be very careful, and you have to go through and say, what is going to fall between 0 and 99 cents? So go through and try to pick out how many that would include. So I got 9 for that. Okay. Now you would go through and figure out how many would fall between 1 and $1.99. And with that, I got 26 values. Okay. So go through each row at a time and highlight or mark those off where you're able to keep up, because otherwise you'll get confused because you'll have so many different numbers to do. Okay. So go through and get the values and the counts for everything else, please. Okay, once you get all your counts, what you want to do next is you want to add them up, and you want to make sure you haven't made a mistake and that it totals the 65. Okay, then it's going to ask you for relative frequency. So I'm going to go ahead and put the total of my frequency is 65. So relative is the part. What part of the data falls in this category? Well, 9 out of 65. This would be 26 out of 65. And you would continue going through. So you just do your part out of your total. Okay. Next, you'll go through and you'll get a decimal for each of those. Now, if you notice and you start getting decimals like this, a lot of times it'll tell you where to round to, but since our data had 2 places, we're going to round to 2 places. So this would be approximately 0.14. The next one would come out to be 0.4. So that's actually equal to 0.4. And then we have 0.17. That actually comes out to be a 0.2. Approximately 0.05. And you got to pay very good attention with rounding because it will mark you wrong. 0.02. And approximately 0.03. Now, if you recall, we're going to add these up. So I'm going to take all those decimals that I've rounded. Since I've rounded, it probably won't be exactly 1. It could be, but it needs to be close to 1. So you can see it's a little bit off. So it's around 1.01. Okay, that's still pretty close, and that's due to rounding error. Okay, so going to histograms. So a histogram is going to be a graphical form. So a graphical form of a frequency, which means you could graph this, okay, or you could graph the relative frequencies. That's going to be called a histogram. In a histogram, you notice that you're having bars, okay? The height right here is either going to be the relative frequency or the frequency. So that's going to be your height. It's either going to be this one or this one, which would be the 0.14, okay? So this is going to be on your y-axis. Your classes are going to be on your x-axis. So that's going to be your class width. So you're going to put those according to how wide that is. So when you're looking at that, this would be my classes with my class width. So when you look at this, you're going to see below that there is a frequency graph and a relative frequency graph. So with the frequency, you're probably going to have whole numbers because it's a count. And with the relative frequency, you're probably going to see your decimals because we're dealing with that percent. Now, if you notice here with the graphs, you still have the x-axis right here, okay? So it's talking about emissions from cars. So we're looking at the data for a car emissions. So when I look at that, we see that they have the same shape. So notice that the shape is the same. The only difference is what I've highlighted right there, which is on your y-axis, which is that vertical scale. Okay, now we're going to look about the visual representation. When you think about the visual representation of a graph, you're looking at the shape. So what impression are you getting when you're looking at that graph? Sometimes you're going to see graphs that are skewed. Now, if it is skewed, one side or tail is longer than the other. So if you notice here, this, when you draw this, this would be skewed, okay? And it would be skewed to the right because the tail right here is going to the right. Sometimes that is called skewed to the right. Sometimes you will see it say positively skewed. Think about that in algebra. If it's going to the right, it's going to positive infinity. So that would be called skewed to the right or positively skewed. Okay, on the second graph, this one is going to the left. So this one right here is going to be skewed to the left. So in the left, you are approaching negative infinity. So that would be negatively skewed. So skewed to the left or negatively skewed. Now, if it is completely symmetric, which means it is a mirror image, the mirror image is exactly the same, then it would be considered symmetric. So if you were to have, and one example of that would be our bell-shaped curve. If you think about a bell-shaped curve, you have that going up and coming back down. You would have everything pretty much symmetric on each side, and it would look more like a bell-shaped curve. And each side would be the same. So with this symmetric histogram, you notice that you have a peak in the middle, and it kind of symbolizes a bell-shaped curve. Okay, so that would be considered symmetric. If it was to be foldable, it would be pretty much symmetric on both sides. Okay, one special name for a symmetric histogram where you have pretty much equal frequencies is, you can see this one right here. It would be symmetric, but it's more uniform, which means most everything's the same. Right here, you've got some low values on each side, and then they kind of go up. But with this one, you basically have everything uniformly distributed. Most things are going to total the same exact thing, whereas this one had a peak. Okay, modes. So with modes, that's the one that occurs the most often. So if you have a peak or high point of a histogram, it is referred to as a mode. A histogram is unimodal if it has only one mode. It's bimodal if it has two distinct modes. Okay, let's take a look at this node in these graphs. So when looking for a mode, you aren't necessarily looking for one highest bar. You're looking for the bar or the bars that have heights or frequencies that are significantly higher than the other bars. So looking in the first histogram above, there are two bars that have heights significantly higher than the others. In the second, there's only one bar that's significantly higher than the other bars. It's pretty close in height. So you can see right here, this one kind of goes up and has a one mode, and then it does that again and comes back up. And so that would have two modes. So it would be higher in this area and this area. So therefore bimodal. With this one, this would be your highest peak. So that would be unimodal. So class midpoints. So this is kind of like in geometry where you had a segment and you had to add both ends and get the midpoint. What you're going to do here is you're going to add the class, both the lower class limit and the upper class limit, and divide it by 2 in order to get the midpoint. So when you look at this, you're going to, first off, you're going to take your 0 plus 0.99 and divide that by 2. So you're going to get your 0.495. Okay, so we're going to round that in just a second. So when you add those two and divide by 2, you would get the 1.495. Now, sometimes they're going to want you to round. So you just need to be very careful with the rounding, because sometimes they'll ask you to round in certain situations, which means that would go to 1.5. Okay. So if it does want you to round, remember that 9 is going to bump the 4 to a 5. Okay. So if I'm doing the 1 plus 199 and divide that by 2, that would be 1.495. I think that's the one I did a while ago by accident. I'll fix that in a second, which is approximately 1.5. Okay, so the other one was 0 plus 0.99. And then I would divide that by 2, and that should be 0.495, which is approximately 0.5. So it just depends on how they're asking you to round. So just be very careful as you're going through that and pay attention to the rounding. So if you notice right here, my class width is 1. So from 0 to 1 is 1. And then if I go from 1 to 2, that's going to be 1 as well. So notice that I'm adding 1 each time. So my next one would be 2.495. Which would be around 2.5. Okay. So if I was adding 1 and going straight down, I would have a 3.5, a 4.5, a 5.5, and a 6.5. So just remember, it's going to be that class width going vertically and stick with whatever it's asking you to round to. Okay. A frequency polygon is constructed by plotting a point for each class. The x coordinate of the point is the class midpoint, and the y coordinate is the frequency or relative frequency. And then points are connected with straight lines. So let's highlight the main things. Okay, a frequency polygon is going to be a polygon that's going to be connected. Now, this part's important. Your x is going to be the class midpoint. The y is going to be the relative frequency. So if you're looking at a polygon, your x is going to be the midpoint, and your y-axis is going to be the relative frequency. And then you're going to see some dots that are connected. You can see it's going up right here, down, and it's just coming back. So it's kind of connected right there. That's a frequency polygon. So looking at this one, this would be a picture of a frequency polygon. So notice right here, we have our midpoints. You can go back and add this part to the y coordinate. It can be the frequency or relative frequency. So remember, frequencies the counts, relative frequencies the decimals. So when we go here to this one, this would be our midpoints right here. And this would be counts. So we have our frequency here, which is our counts. Okay. So you can see how you have these dots and then they're kind of connected. Now, an ogive and a cumulative frequency. Cumulative frequency is the sum. That part's important. The sum of the frequencies of that class and all classes before it. Cumulative relative frequencies are calculated in the same way. Consider the classes here with the emissions data from earlier. So notice we have our counts and we're trying to get now the cumulative frequency. So this is a new word. So where we're going to start is we're going to start with this first count, 9. And then what you do next is you take the 26 and you add 9 to it. That's going to be 35. Then you take your 11 and you add the 35. So we're doing a total. That's going to be 46. Then you take the 13 and you add the 46 you already have. And that's going to be your 59. You take the 3 from that and you add the 59 total, which is 62. Then you have the 1 plus the 62, which is 63. And you have 2 plus 63, which gives you a total of 65. So 65 is going to be the total number of values. So what this does is it takes the class and it adds the next class to it. Then it takes this class and adds your total. So you keep adding cumulatively. Kind of like when you have a cumulative exam, it's a total of all those chapters. So you're taking what you have learned and you're adding it to the next part that you are learning. So you're totaling everything up. Now, as we finish this word ogive, what's going to be important about that is it's used to represent a cumulative frequency. So the very tip top right there is going to tell how many people were surveyed. So if I look at that and I come across and I kind of line that up, you would be able to see. So I'm kind of go across. And you can kind of see that's around 65, like we got. So that's going to be your total. So if a question asks you about the total, that's going to be in an ogive because it's a cumulative frequency and it's going to occur at the end point right here. Okay. So when you look at that, the x coordinate, if it asks about this, that's going to be your upper class limit. So those are your upper class limits. This right here is the cumulative frequency. So notice this is growing each time. So I believe we started off somewhere around 9, and then we went to 35, 46, 59, 62, 63, and ended at 65. Okay. So your y-axis is going to be the cumulative frequencies, the y-axis. The x-axis is going to be your upper class limits. That would be the upper class limits. Okay. Let me know if you have any questions. Good luck on your work. Hope you stay safe. I'll see you soon.